Welcome back to another section of my tutorial, and I have a problem in applied electricity. And the problem says two batteries A and B are connected in parallel, and an 80 ohm resistor is connected across the battery terminals. The EMF and the internal resistance of the battery A are 100 volts and 5 ohms respectively, and the corresponding values for battery B are 95 volts and 3 ohm respectively. Find the value of the current in battery A, and then find the current in the 80 ohm resistor. So to go about this question, you have to draw the diagram for the statement written above. So in order to deduce an electrical circuit connection from this, you have to follow what the statement is saying stepwise. So let's say two batteries A and B are connected in parallel. So if you're having batteries, let's write our solution. So if you're having batteries connected in parallel, you have one as this, then the other will be somewhere like this, then the two of them will be connected in parallel like this in the other terminal. But let's see, it said and an 80 ohm resistor is connected across the battery and the terminals. Now, since these batteries are having internal resistors, we are supposed to introduce an internal resistance here or anywhere around the terminals. So each battery is having an internal resistance. So across the two parallel connections, that is where we have the 80 ohm resistor being connected across them. So we have another 80 ohm resistor connected across this parallel connection. So this will be our 80 ohm resistor. Then let this be battery A. Battery A is having 100 volts here, as well as it is having a 5 ohm internal resistance. Now for battery B, it is having 95 volts as well as a 3 ohm internal resistance. So let's see, from here we have to calculate the value of the current A from battery A. So we want to find the current coming from this battery A or produced by the battery A. So now that we have our diagram here, let's move ahead by introducing the currents from the various sources. So we have two sources here. So let the current coming from the battery A to be, let's say, I1, and the current coming from the battery B to be I2. Now current flows from the positive to negative, that's why the direction will face this way. Then this one to the direction will face this way. Since they are connected in parallel, the negative will go for the negative and the positive will go for the positive. So here I will introduce my I2 here. Then together they will meet at the junction, and by Kirchhoff's current law, they will form I to pass through here. When it reaches here, it will split back again to their various components. So now from here, let's apply the Kirchhoff's loop law or the voltage law and create a loop. Once we find a loop, we sum up all the voltage drops and we equate it to the voltage sources. So now let's find our first loop. We have to find the current in battery A. So let's see, if I take this loop, you move from battery A, you come down and you pass here. This forms a complete loop. So this is one loop. So taking that loop, I'm having my source to be 100 volts. Then if you are having the source to be 100 volts, in this loop you are having voltage drops. A voltage will be dropped across the 5 ohm resistor. So 100 volts will be equal to the 5 multiplied by I1 in the same direction, here too, plus this 80 ohms, and the current is I. So here I'm going to get 100 is equal to 5I1 plus 80 open brackets I1 plus I2, since the I is a combination of I1 plus I2. So this will further give me 100 is equal to 5I1 plus 80I1 plus 80I2. Hence finally I'm going to have 100 is equal to 85I1 plus 80I2 as my equation 1. Now for the second part, I'm going to take this loop. I'll move from here, I'll move up, I'll come here, and this is another loop I'm having as my second loop. So for the second loop, I'm having the voltage source to be 95, and it's equal to a drop here, which is 3 multiplying I2, plus finally the 80 by I. So this will also give me 95 is equal to 3I2 is the same as 80I1 plus 80I2. So I get 83I2 plus 80I1. Equation 2. From this point, I can find the value of I1 and I2 as the current coming from the 100-volt source and the 95-volt source respectively. So you solve this simultaneously. So you punch it into your calculator. You punch the two equations separately. So you have 85, 80, then 100. Then you come and punch the second equation. You have 80, 83, then 95. So what is the current are you getting? So we are getting I1, which is the current coming from the battery A, to be equal to 1.069, which is also equal to 1.07 amperes to 2 decimal place. Now let's see I2. I2 is the current coming from the B, or coming from the battery B, and that is giving me 0.115 amperes nicely. So let's see. So this answers the A part. So the A is saying that find the value of the current in the battery A. So from here you can see that the value of the current from the battery A is the same as the I1, as we shown I1 coming from the battery A. So from here you see that current from the battery A is equal to 1.07 amps. Now let's see, say find the current in the 80 ohm resistor. We know that the 80 ohm resistor contains the current or combined current from the two voltage sources. So current in, that is the B, will be equal to the I1 plus I2, and this is equal to, you add the two current you're having, then the sum will give us the current from the 80 ohms. So you're going to have 1.07 plus 0.115, and that will give us 1.185 amps, as simple like that. So whenever they give you an electrical problem or any problem in applied electricity, you have to make sure that you draw your diagram from the statement given, then you state your equations from either the Kirchhoff's law or the various circuit laws that you have. This is the end of my video. Thank you for watching. Kindly subscribe and share.